Welcome back to the deep dive. Today we're going to get our hands a little dirty with some pretty technical specs.
We are.
We're looking at the Kramer C-4LC 4LC 164 4LC fiber optic cable, and our mission is to break down what all those dense specs actually mean for you.
Right. This is all about functional clarity.
Yeah.
For anyone out there working with commercial AV, understanding how a piece of hardware like this is engineered, I mean, that's everything.
It is.
We're not just reading a data sheet. We're trying to figure out what problems these specs are actually solving.
Absolutely. So this specific cable, the C4LC 4LC 164, is 164 feet long, which is what, about 50 meters?
50 meters.
But the length isn't what really jumps out at me. It's the construction.
It's a quad cable, right?
It is.
So why 4 separate fibers? Why not just one? What's the thinking there?
Now that is where it gets really interesting. That construction is there for a very specific reason, and it has everything to do with DVI and HDMI.
Okay.
You see, the cable is actually 4 distinct color-coded simplex components inside. They've got red, green, blue, and orange.
Right. And in a digital video signal like DVI, you need 3 channels for your main data, the TNBS signals, and then a 4th for things like the clock signal. That quad structure gives you 4 clean, isolated paths.
So it's basically a physical mirror of the DVI and HDMI signal structure itself. That makes perfect sense.
Exactly.
So let's talk about what those channels are made of. Each one is a multimode 50125 meter simplex cable. What does that fiber type tell us?
Okay, so that multimode 50125 meter part is key. That's the diameter of the core and the cladding.
Right.
And choosing multimode fiber for this kind of distance, for 164 feet, is a very deliberate engineering choice. It gives you the massive bandwidth you need for high-res video, but you don't have to use expensive single-mode lasers, which are, total overkill for anything but super long-distance runs.
Got it. So it's a balance of performance and cost. Now, looking at the specs, 2 acronyms jump out, OFNR and TAA. What do those mean in a practical sense?
Well, they tell you this is a professional, compliant piece of gear. OFNR stands for Optical Fiber Non-Conductive Riser.
Riser. Okay.
It's a fire safety rating. It means you can run this cable vertically between floors in a building without needing to put it in a metal conduit. And TAA compliant just means it's approved for use in, say, government projects. High-quality sourcing.
So that tells you right away this is not a consumer product.
Yeah.
Now, let's talk about the connections. It uses standard LC connectors, and it's made to work with specific Kramer gear, like the 610TR series.
And if you look at the performance, it's just superb. It operates at an 850 nanometer wavelength, which is pretty standard. But the really incredible spec here is the insertion loss. It's only 0.3 dB.
0.3, wow.
I mean, that is a tiny, tiny amount of signal power to lose. It basically guarantees your signal is going to be pristine from one end to the other.
And that reliability is also baked into the physical design, isn't it? The operating temperature range is, honestly, it's extreme. -40 all the way up to 80 degrees Celsius.
Oh, yeah. It's built like a tank.
And while this model is the 164-foot one, it's worth noting you can get these in versions all the way up to 1640 feet.
So I think the main takeaway for you, listening, is that every single one of these specs, the color coding, the 0.3 dB loss, the OFNR rating, it's all there to take the guesswork out of a professional AV installation. It's engineered to just work.
And that leads us to our final thought for you to chew on. We know this quad structure is designed for the 4 standard DVI and HDMI channels, but what if you didn't use it that way? What kind of future-proofing or advanced diagnostics could a system designer build in if they used one of those 4 independent fiber paths for their own custom side-channel communication? Something to think about.